Morning, children. In continuation of chapter Magnetism, today we will discuss about properties of a magnet. First one, attractive property of magnet. Magnets have the property of attracting certain metals and alloys toward them. A magnet attracts magnetic substances like iron, cobalt, nickel, by exerting a force called magnetic force. The region around the magnet where its magnetic force can be experienced is called its magnetic field. Now, second property is poles of a magnet. Children, this activity shows that the end of the magnet that attract most of the iron filings are called its poles. Each magnet has two poles, namely the north pole and the south pole. The attractive power of the bar magnet gradually reduces as we move from the ends towards the center of the magnet, where it is partially zero. Now, third property is directive property. A freely suspended magnet always points in the geographical north and south direction. Take a bar magnet and suspend it by a string tied to its middle so that it hangs freely. You will notice that the magnet always comes to the rest in north-south direction. Disturb it again, you will notice that when at rest, it will again point in same directions, that is north-south direction. So we can say a freely suspended magnet always points in north-south direction. Now, fourth property, magnetic poles exist in pairs. Magnetic poles always exist in pair. Every magnet has two poles, north pole and south pole. They can never be separated from a single north pole or south pole single. They always exist in pair. Suppose that a bar magnet is broken into two equal parts. Each part will be magnets with its own north and south poles. If the pieces are again broken into two parts each, it can be shown that each of the smaller parts has a north pole and south pole and is a magnet itself. Now, fifth last property is attraction and repulsion between magnets. In this activity, suspend a magnet from a wooden stand with the thread. It would come to rest in north-south direction. Bring the north pole of the another magnet near the north pole of the suspended magnet. You will observe that north pole of freely suspended magnet is repelled. Now, bring the south pole of another magnet near the south pole of the suspended magnet. You again observe that repulsion of the south pole of the freely suspended magnet. This shows that like poles of the two magnets repel to each other. Now, bring the south pole of second magnet near the north pole of the suspended magnet. In this case, you will see that attraction each other. When this activity is done in the reverse manner, the same result is obtained. This shows that the unlike pole attract to each other. Means when we brought a close to each other, north pole repel and the north pole but attract the south pole. Also a south pole repel another south pole but attracts the north. Now, test for a magnet. By this activity, we can conclude that if a magnet bar is a magnet or not. Keep a metal bar on the wooden table. Bring one pole, say the north pole of the magnet, close to the end of the metal bar, one by one. Okay. If one end is attracted and another repelled, then the metal bar is magnet. If both ends are attracted, then the metal bar is not magnet. From this activity, conclude that the repulsion is the surest test for magnetism. Now, next topic is magnetic field. The force exerted by magnet is called as magnetic force. It is non-contact force because it acts from a distance. Okay. Each magnet has certain region around it within which its magnetic force can be experienced. The region in which the magnetic force of a magnet is felt by other magnet or magnetic material is called its magnetic field. A magnetic field is represented using curved lines called as magnetic lines of force. Magnetic lines of force are considered to be originate from the north pole of the magnet and moves towards the south pole. Now, properties of magnetic lines of force. First one, magnetic lines of force are continuous curve. Second one, outside a magnet, the magnetic lines of force begin from north pole and end its south pole. Third one, no two lines of force ever intersect at a point. Fourth one, densely populated lines of force indicate a strong magnetic field, whereas widely distributed lines indicate a weak magnetic field. Now, fifth one, magnetic lines of force shows the direction of magnetic field at each point around the magnet. Children, it is all about properties of magnet and properties of magnetic lines of force. Okay, thank you.